In this video, we'll talk about planes in space. Given a fixed point P0 and a non-zero normal vector n, the set of all points P in R3 for which P0 P, so P can be here or it can be here, but so that P0 P it's orthogonal to n, that means n it's perpendicular on all those, it's called a plane. So this would be the plane, so that n is the normal vector to that plane. It's perpendicular to the plane. So the general equation of a plane in R3, the equation, it's given by, well, let's deduce it. So if we have P0 P, it's the vector given by, well, if P is XYZ, then P0 P is X minus X0, Y minus Y0, and Z minus Z0. So they're written in component form. Now we know by definition that P0 P is perpendicular to n, so that means the dot product of the vector P0 P and n is 0, because we know the dot product is P0 P times n, the magnitude of those, times cosine of the angle between them, and since they are orthogonal, it's cosine of 90 degrees, which is 0. Now P0 P is X minus X0, Y minus Y0, Z minus Z0 times the vector n. Let's say vector n is has the components ABC. So this would be ABC. It's equal to 0, but we know how to do the dot product, right? This is the dot product, and we get A times X minus X0 plus B times Y minus Y0 plus C times Z minus Z0 equals 0. This is the equation of a plane in R3. But we can also open up the parentheses, expand, so we get AX minus AX0 plus BY minus BY0 plus CZ minus CZ0 equals 0. Now if we write this together and we move these terms on the other side, we get AX plus BY plus CZ equals AX0 plus BY0 plus CZ0. And if we rename this as D, we can write the equation as AX plus BY plus CZ equals D. So again, the equation of the plane in R3 in a different format, right? So we have two equations. We have this one, where X0, Y0, Z0 are the coordinates of the point, and ABC are the components of the normal vector, or AB plus BY plus CZ equals D. Let's do an example. Find the equation of a plane passing through the point A of coordinates 1, 2, 3 with normal vector n of components negative 1, 2, 3, 2, 4. Plane would be negative 1 times X minus 1 plus 2 times Y minus 2 plus 4 times Z minus 3 equals 0, where negative 1, 2, and 4 are given by the components of n, and 1, 2, and 3 are given by the coordinates of A, and negative are from the definition. So if we open up the parentheses, we get negative X plus 1 plus 2y minus 4 plus 4z minus 12 equals 0, which is negative x plus 2y plus 4z equals 15. So this is the equation of the plane. Let's graph the plane we got in using GeoGebra, just so that we have an idea how it looks like. So I open GeoGebra and then we go to this symbol here and then to 3 dots and we choose 3D graphics. And I'm going to close these 2 graphics. So close 2 by 2. So we have a 3 by 3. And now I'm going to write here the equation of the plane I want to graph. Negative x plus 2y plus 4z equals 15. And I'm going to go to here and I'm going to go to settings and I want to choose the color to be green. And so we can see, or I can choose blue, for example, or I can choose red. So we can see that the plane that we just found out, it's given by this graph here. And let's do one more problem. Find the equation of a plane that passes through the points P1, P2, P3. So in order to do that, I'm going to calculate vector P1, P2, which is given by 2 minus 1, so it's 1, 3 minus 0, which is 3, and 4 minus 3, which is 1. And then I'm going to calculate P1, P3, which is negative 1 minus 1, so it's negative 2, 1 minus 0, 1, and 1 minus 3, negative 2. And so to find the normal vector to the plane made by P1, P2, P3, I'm going to calculate P1, P2 cross product P1, P3. So we get I, j, k, we're calculating the determinant, and then we put 1, 3, 1, and negative 2, 1, negative 2. So we get I times, if we cross out, we get negative 6 minus 1, that's negative 7, minus j, this minus is from the definition, minus j, and then negative 2 plus 2, and then plus k, and that gives us 1 plus 6. So we get negative 7i plus 7k. So the normal vector is negative 7, 0, 7. So we have that it's the normal is negative 7, 0, 7, and we use the point P1 because it's the intersection of these two. So P1 is of coordinates 1, 0, 3, and the normal vector is negative 7, 0, 7. So the equation of the plane is negative 7 x minus 1 plus 0 y minus 0 plus 7 z minus 3 equals 0, which gives us negative 7x plus 7. This quantity is 0 plus 7z minus 21 equals 0, which gives us negative 7x plus 7z equals 14. We can divide everything by negative 7 and we get x minus z equals negative 2, and this would be the equation of the plane. So now that we have these results, let's graph it. So let's graph the plane that we just got. X minus z equals -2. So we got this green one, right? This is the plane we obtained. Now let's try and graph it using the 3 points. Let's say A equals, so the problem had 1, 0, 3. Then I want B of coordinates 2, 3, 4, and I want C of coordinates -1, 1, 1. And I'm going to this, and I'm going to say plane through 3 points, and I'm going to choose the 3 points, A, B, C. So the plane, again, if we notice, it's the same plane that was graphed. I can even choose a different color. Activated this one, which was green, and we can see this plane with pink. So again, it's exactly the same plane because we did the work and that's what we obtained. And so I showed you how to draw it using the equation of the plane and using the 3 points.